All right. Please welcome our next speaker, Peter Pizzimenti from Syracuse University.
1 second here. Okay. Okay, anyone hear me? Yeah, excellent. Okay. So my name is Peter Pizzimenti. I am from Syracuse University, and I'm here to represent the research computing team at SU. Let's start off with a little bit of a story. Working on these slides with, my team members. It's like I said, hey, I want to go over my slide deck because it's just not me speaking. It's me representing the entire team in the university. I want to make sure I get out the proper wording, the proper tone, and we cover all the bases. So I just want to do a quick overview of all my slides real quick. I'm not going to go through the whole speech and you just let me know what you think. So I do all that. It's like, okay, so that's it. I skipped a couple of slides. Don't worry about it. I'll pick it up. And one of my team members says, like, yeah, so how long is your presentation? He's like, I got 20 minutes. He's like, your overview took 25. So what I've done is I clipped a couple of slides. Marone, sorry, I pulled all the stuff about authorization and identity. I apologize about that. Identifier, so on and so forth. I really don't know what we use. I think it's a Dewey Decimal System, blockchain, something like that. So you're not missing anything. So what I'd like to do is, okay. Yeah, somebody help me out. There you go. Nope. It's just. Yeah, I know.
The focus problem usually. No? Oh, it's on.
Oh, yeah, I'll do it. Did you plug it in? No, I did not plug it in. Yeah, I made that mistake telling people that too. It's all right. No, we're good. No, that's a very good question. Hey, there we go. So I turned it off and gone the wrong way. Okay, so what was I saying? Peter Pizzimenti. Yeah, I take too long when I talk. Apologize about that. And I also screw up slides. So I like to do, like, in this presentation, I like to kind of walk through what it's like to support research computing at Syracuse University. There we go. Back to this one. And I want to do that, and taking steps on a certain path. So I'm gonna break the presentation up into three sections. Why we invest, what it takes, and where we are going. So okay. So why we invest, Syracuse University. So Syracuse is an R1 institution with a wide array of research from chemistry to physics, from social science to visual arts. These researchers have, much like with everybody else, they do have a wide array of specialized needs, and they come to us first to support that need. I remember probably one of the first projects I worked on with a researcher was in photogrammetry. So he takes a lot of pictures of things, turns them into 3D objects. You move that object around, photorealistic, very interesting. What he did is he did that in an art gallery, and he made it into a virtual reality tour. So what he did is he's like, hey, I want to show you this thing that I'm working on. He puts a headset on me. He's like, just kind of walk around, and I did that. What he failed to do is set up the virtual boundaries in virtual reality, and the first thing I did was walk into a wall. So that was my first introduction into research computing. Another thing is that the campus has demand for a diverse a diverse amount of computing infrastructure. It's not just HTC, it's not just HPC. It could be the need for interactive nodes, interactive Windows nodes, something with a GUI, Linux, maybe some type of cloud resource. And they come to us for that. And we try to do this in a most centralized way. And that gives us a consistent way of providing service. And also, another way, because they come to us and part of this group, it also strengthens our purchasing power. So when instead of disparate groups making small purchases here and there, what we can do is we can combine those funds and work with the vendor, make a large purchase all at once. Beyond that, we try to provide compute at no cost. And we do this for quite a few reasons. First and foremost, it is that it can amplify grant dollars. So when a researcher comes in that has some amount of funds, usually one of the first things that they ask when they're not familiar with our group is, what's a compute hour going to cost me? And we can tell them, well, it doesn't really cost you anything. You can use those dollars instead, buy some more microscopes, or purchase licensing for proprietary software, something we don't all immediately provide, or increase your lab staff size. Another thing that this does is that it provides opportunities for those without formal funding. We believe that funding shouldn't get in the way of a good idea. And if we have the resources available for that researcher to do that work, we want them to be able to do it. I didn't buy the servers for myself. If it's sitting there doing nothing, I probably shouldn't have bought it in the first place. So I want to make sure that everyone has as much access as they need when they need it. Another thing with this is that it is also a strategic advantage, marketing advantage for Syracuse University. When I sit in meetings with prospective faculty, and again, we talk about budgeting or startup funds or things that they're coming up with, and I tell them, there isn't any cost to use this infrastructure. Big old smile on the face. Knowing that they can take those startup dollars and put it towards the things that we talked about: people, more equipment, things, and so on. So on this slide, I had, why we invest beyond, impact beyond Syracuse University. And I had these two top bullet points. First, over 1 billion CPU hours contributed to the OSG via Orange Grid. And that we're one of, I believe, 6 path facilities in the country. And I had a bit on my laptop, and I'm not going to read it, because the one thing that came to me when sitting here for the first time is that this is the first time I've been able to put a name, a face to a project, right? To see what people are accomplishing on this resource that we are part of. It's easy to abstract away. I go look at that server, it's making a lot of noise. I'm sure someone's doing something very interesting on that. And to see that interesting thing up close and personal, and how that impacts that researcher and their research, and how they're able to move forward with the science, it is very uplifting. I do appreciate some of the shout outs that we got earlier for what we contributed, things like that. I feel very humbled for that. And again, it's very nice to see the users, up close and personal, and what they're doing on these facilities. And lastly, expanding, national research and impact partnerships outside the university. So along with the OS pool and PATH, and we have researchers that have collaborators all across the country and all across the world. And we make sure that just because they aren't necessarily physically located on campus, or don't necessarily have the direct affiliation of being, a faculty member of the research, if they're part of that research group, we make sure we bring them in, we integrate them in the way that we do things, and we provide them the same access as those that they're collaborating with. So,
I want to comment here that this billion contribution is two-way because Syracuse was one of the campuses that will come back to us and complain. We are giving you the capacity and you're not using it. What's wrong with you guys? How can you do better to you? So that's and we had to clean up some of our acts in order to do better with what is offered. But the push from Syracuse helped us to do better. And you can argue that's part of the translational thing. You can add it to in 1 or 2 minutes on my account. So I want to hit it here, not at the end. The importance of this partnership with Syracuse and going back and forth.
excellent, thank you. So I want to talk about what it takes, people and resources. So we're not an insular group. While there may be a few of us part of that group, and we do support a lot of things, we are part of a whole. So in our research computing team, we focus on delivering large-scale computing systems like our Orange Grid cluster, which I'll get to in a moment. Provide direct support for and the researchers using them. And we try to be more than just system administrators. We strive to be collaborators and problem solvers, especially for that new researcher. We are acutely aware that if this is your first time using these types of resources, I'm asking you to SSH into a Linux server, and you're greeted with a black screen and a blinking cursor. Go forth and do science. The knowing that and making sure that they have the resources available to them, either with us personally or online resources that that can provide them some type of self-service, is really important, because we know that black screen and blinking cursor can be quite intimidating. We also rely heavily on other specialized groups, specialized IT groups across campus. For example, I think one of the things that makes us maybe a little unique is that a lot of the services that may be internalized into a research computing team, maybe through purchasing or networking or storage, we look to the specialists that also run the part of the enterprise and production parts of our IT systems on campus, and we look to them to provide these resources to us. And that allows us to focus on our main objective, which is research computing, while allowing them to focus on their main objective of maybe networking or storage. A good recent example of this with storage is that we are currently moving away from our ZFS NFS servers. We have about 60, 70 of them. We had a good model 10 years ago, and we just kept adding to it to the point where it started to collapse under its own weight. So we could do a lot of things. I really like ZFS. It's an excellent file system. If I could make that bigger and do more with it, I would. It's not the fault of ZFS. I would say it's just that the infrastructure that we put ZFS on just isn't at the place to support the scale that we are now. So instead of going out, building another storage system, working with vendors, having a particular storage system just for research computing, we went to our core infrastructure services team. They have storage administrators. They do this all day. And they have services that we can consume. So we're currently in the process of migrating about 1.5 petabytes of home directory storage off these NFS servers directly on exports on our NetApp cluster. I am I worked in infrastructure for a very long time, and only recently have gotten, a title change. So it's difficult for me to not kind of fall back on some of the nerd pieces of what I do, but I do enjoy it. And talking about this particular part with the storage, it's like we're now able to change the default allocation for a researcher for their home directory. Every researcher in the door, previous and future, will get a home directory by default of 4 terabytes. In the beginning, we could only do a maximum about 60 terabytes per home directory. Now we can do 300. Users can have up to 2 million files open up simultaneously, probably more. I stopped counting. Those home directories can have up to 2 billion files or inodes without affecting themselves or those around them. And being able to do that is no small undertaking. So just being part of the team, those who are the specialists in this, is very important for us to take advantage of that specialization. Resources and community. We provide personalized onboarding for every new researcher. It's usually short, 15 minutes. What we do is we ask them to talk about their research and their workflow and their desired outcomes. And we try to walk them through the choices that we have, and try to line them up based on our past experiences with the resource that we think they'll be most successful on. It doesn't necessarily need to be the big iron cluster. Research can happen, good research can happen on small compute. And if that's what we need and that's what they need, that's what they have access to. Next is the knowledge ecosystem. We have quite a plethora of online documentation and GitHub repositories showing hello world examples of common software applications that's run on our cluster. Then back to that black screen, blinking cursor, where to start. You pull this repository if you're working in Python or working in R or even working in Blender, and you want to be able to scale that out on the research cluster. We got you covered, at least in the beginning piece, to the part where you can see how we did it, remove our pieces and insert your own. Next is our research computing speaking series. With this, twice a semester, we ask researchers across campus to speak about their research project to others of the community, for them to have that voice. For some of them, especially for some of the students, this may be the first time they've ever spoken about their research project. And this gives them a safe place, where they can do this ums and ahs and ohs and I'm not sure, and they can do that in a crowd of their peers, a crowd of their friends, and get that experience for the next time they need to do that. We also opened this series up to experts outside of the university to speak about the things that we're working on. Some of those experts are in this room. Christina and Greg, thank you very much for presenting at our talk last year. These experts provide a lot of useful information and interesting ways to getting work done that a researcher may not have been aware of. So what it takes infrastructure. So I'm gonna go through these next two fairly quickly, because I want to get to the last one. The last slide's pretty exciting. We get to look at kind of the whiteboard, the thing that we're working on next. So what it takes infrastructure. Orange Grid. Orange Grid is our 80,000 core dedicated 80,000 dedicated core high through computing cluster running HD Condor. It also has 10,000 scavenged nodes. These scavenged nodes, which I'll go into a little bit more, come from desktops across campus that get added automatically. Zest is our 25,000 core Slurm cluster. Its big claim to fame is that it has InfiniBand interconnects. Next is Surge. So Surge is an interesting piece. This is a logical unit container that has all our GPUs. Range from RTX 5000s to 80 gig A100s. Interesting piece about Surge is that we're able to dynamically allocate GPUs from this pile to either of these clusters based on demand. And lastly is the the academic virtual hosting environment. We're not great at naming anything. Sorry about that. It really rolls off the tongue. But the AVHE for short. This is our private cloud. You know, for when a user needs something bigger than a desktop but smaller than a cluster, they can go here and get that Windows machine or Linux machine. What it takes up close for OrangeGrid, our HTC cluster. Okay, so quickly, we take about 90% of our on-prem data centers, and that 90% works on almost any way you measure it. Noise, heat, wattage, space. Yeah, we kind of cover everything, kind of like moss, kind of grow on anything. We're not paying attention. He's like, oh, research computing stuff is here. How'd that get there? What we do is we do everything through virtualization. This allows us to be very flexible with the type of work that runs in this cluster. When we need to do something else, we could turn a virtual machine off, turn a new virtual machine on that happens to be on that same host very quickly to swap out our needs based on demand. Next, the Condor Virtual Machine Coordinator. Again, not great at naming things. This is the tooling that gets all our scavenge nodes. So this goes across campus and looks at idle desktops and taps into that once untapped resource, spins up a virtual machine on that desktop, and then that virtual machine is then plugged into our Condor cluster, providing ephemeral nodes to that cluster when the machine is not in use. And lastly for this is our self-service software model. I think this may be a little different, not 100% sure, but we don't install very much at all research-specific software on our worker nodes. What we do instead is we have our worker nodes, when they get a job, mount that user's home directory as that user. This way, any binary that they have installed in their home directory, either Conda, something they compiled themselves, or Apptainer, that file folder structure, the one that they're already familiar with on maybe their standalone machine, relatively it's all the same. They don't need to package anything up. They don't send more data than they need because we just mount everything. They don't send anything at all. Just the files that need to be connected to and looked at are the files that are accessed. Where we're going first, this is my last slide. So we're looking to augment with the public cloud. Okay, quick. One of the things that we're trying to do is take these interactive pet nodes, these nodes with names, things assigned to someone, the things that a researcher knows and loves. Those can be difficult to keep up, maintain, take care of, life cycle. They will live on forever. They'll stay under a desk till the end of time. You know, a new researcher will come in, like, what's this computer? It's like, I don't know, don't turn it off. I'm sure it's something for somebody. And we're moving it to the cloud. We can look at more of a systematic way to doing life cycle. The next, and it flows into this last part, is the multi-cloud spot market approach. So looking to augment our on-premise cluster with bursting into the public cloud using spot market approach. So this usually, how this works when you do this type of bursting is that you pick your particular poison with a cloud researcher. This is how AWS does this. This is how Azure does this. I'm interested in sampling everybody's poison. And the way I want to do that is by deploying a node on whichever cloud on any instance that is cheapest at that time. I don't care where it is. I just care how much it costs. And if you can give me a Linux endpoint and an IP address, I will get it connected to my cluster. How are we going to do this? So cloud agnostic tooling. We're going to use tools like Terraform, things we're going to take advantage of someone else's hard work. We're going to use these APIs and deploy virtual machines on Azure and GCP and Linode and Oracle, whoever can provide us at that time. We're going to use Ansible Poll to build that machine via Bootstrap. I'm going to tell this machine, hey, you're a worker node. Goes out to GitHub, gets that information, does that configuration, connects to the cluster. We're going to use, don't follow me on this one. This one's dangerous, I know, but it's still scaffolding. We're going to use NFS over the WAN on a VPN. Oh my God, don't do that. Seriously, don't do that. But, you know, as scaffolding to get it set up, I'm looking to extend what we're currently doing without redoing everything. So at least in the beginning, this is what we're looking at. How am I going to tie this thing all together? They're all over the place, and there's firewalls and in NATs and all this weird routing. I'm going to look to overlay networks. I'm going to look to technologies like UDP hole punching. It's going to build peer-to-peer or flat peer-to-peer networks that all the machines look to be part of the same subnet. That it'll be able to connect without port forwarding, without the worry of firewall rules. And that'll be a flat network on a single subnet, bringing all those things together. So with that, I wanted to say thank you. And if there's any questions beyond this, you can send questions to our research computing esquire.edu. Left a QR code up on the screen. This brings you to our landing site for a lot of our documentation materials and links to our GitHub. Thank you.
So one quick question for this bursting next step. Can we be involved in it?
Absolutely.
And if the answer is absolutely, let's talk obviously offline on how and what, because we have some experience with other sites. We have not done any bursting here because we don't have clientele for it.
Yep.
So we would definitely be interested, and I know the Todd and company are definitely interested in the overlay network. They haven't been giving me a hard time for a long time, and I said I don't believe it works. So
but it does.
so let's see what. I mean, it was not overlay; it was virtual.
Yeah.
But just for the sake of the discussion, we would very much like to see whether we can be part of this exercise.
Yep. Yeah. All those tools that I had up, we've all used in one way or another. The interesting part is we put all those tools together to kind of make this thing work. You know, the overlay network is really the linchpin to this. I mean, having spot marketing and kind of going to lowest bidder, that's also very important too. But kind of putting all those things together in a way where I don't necessarily have to go to the networking team on any side. I don't want all this stuff exposed to the internet. I just want it to be on a 10 dot address. Okay, it's on a 10 dot address that's in Germany. It's in a 10 dot address in California, New York. Put all those things together, wrap it in something like WireGuard, nice and flat, very simple. That's the hope. That's the hope.
Since you're willing to do the risk, we would like to leverage you. You know, we are scavengers.
Coming to a GitHub